Hello students, welcome to the student brand. This is our Siva sir. Today we are going to discuss about current electricity. Current electricity, okay, current electricity, grade 12 physics. Okay, so what is electric current? What is electric current? Electric current is nothing but electric current. Okay, electric current. I equal to Q by T. The rate of flow of net charge through a cross-sectional area. Through a cross-sectional area. The rate of flow of net charge through a cross-sectional area is called electric current. And here I equal to Q by T, I equal to dQ by dt. So this is the instantaneous current. Instantaneous current, a current at particular instant. Current at the particular instant. I equal to dQ by dt. I equal to dQ by dt. So what is SI unit of current? SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So what is SI unit of current? SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. So now you can see the flow of charge can be obtained. The flow of charge can be obtained by multiplying. First one. The flow of charge can be obtained by multiplying constant current with a change in interval. And coming to the next one, if current is the function of time, if it is the current is a function of time, then the flow of charge can be, okay, so obtain di df I equal to dt. And coming to third one is, so the charge can be obtained by the area under I and T graph. Okay, the charge can be obtained by area under the I current and time graph. Yes or no? So here you can see current on x-axis, time on y-axis, the graph. Okay, current time can be obtained. Okay, so current can be obtained, charge can be obtained, the flow of charge can be obtained by area under the IT graph, that is charge. Yes, sir. Also, these are points you can observe here. These are points, right? Yes or no? So electric current I equal to dq by dt. Okay, so the instantaneous current. Okay. Now we'll discuss about. So current can be divided based on magnitude and direction. Current can be divided based on magnitude of the direction and direction. Current can be divided based on the magnitude and direction. So the current at particular instant, is called instantaneous current. Instantaneous current. Yes or no? Yes or no? Yes. So now based on magnitude and direction, current can be divided. Oh my God. Based on the magnitude and direction, current can be divided into two types. Current can be divided into two types. The direct current and alternate current. First one is direct current. Second one is alternative current. So what is direct current? Direct current is nothing but, okay, direct current is nothing but, so the magnitude and direction does not change with time. The magnitude and direction does not change with time. That is called direct current. Example, cell, battery, DC dynamo. What are those? Cell, battery, DC dynamo. What are those? Cell, battery, DC dynamo. And coming to alternative current. What is alternative current? Alternative current. Both magnitude and direction changes with respect to time. Yes or no? Both magnitude and direction changes with respect to time. That is called alternative current. What is that? Alternative current. Example, AC dynamo. What are those? Example, AC dynamo. Right? Yes or no? I hope it is very clear. Yes. Cell, battery, DC dynamo and AC dynamo. So these are, and one more thing, if the charge is moving, if the charge is moving in a circular path with frequency f, if a charge is moving in a circular path with frequency f, then current can be written I equal to QF. Okay, I equal to QF. Charge is integral multiple of electrons. So Q equal to plus or minus Ne. Sir, if only one electron flows, will you say current is flowing? Only two electrons flows, will you say current is flowing? We can't say like that. No, only one electron flows, will you say current is flowing? Only two electrons? No. Three electrons? No. Four electrons? No. We can't say only 1, 2, 3 electrons goes. We can't say current is flowing. There are number of charges, number of electrons are moving in the conductor. Then only we can say current is flowing. That is called quantization of charge. What is that? Quantization of charge. Q equal to plus or minus Ne. Q equal to plus or minus Ne. And 1 electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. And 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons present. Yes, yes. I hope it is very clear, right? Okay. So next one we are discussing about drift velocity and relaxation time. Drift velocity, 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 relaxation time. So now we are discussing about drift velocity and relaxation time. Drift velocity, drift velocity, and the relaxation time. Relaxation. Okay. Drift velocity and relaxation. Okay, so what are those things? Relaxation time. So what is the drift velocity? So when electrons are moving in a closed conductor, yes or no? They are moving in a closed conductor. So when 2 members or 3 members are moving in a row, so what will happen? Will fall on one each other, will fall on another, that person fall another. Whereas the electrons, so many electrons are moving in a closed path. in one direction, then what happens? One electron will go and hit another electron. That electron will go into another electron. Yes or no? So one electron, so will go and hit another electron. That electron will go and hit another electron. Yes, collisions. That what happens? Collision takes place. One electron. Come on, one. Go. Like a fighting. Then collision will take place. Dishka. Like that, collision will take place between electrons. Yes or no? One electron will go and hit another electron. Disha. That electron will go and hit another electron. Disha. Then collisions will take place. Yes or no? So one electron is moving with some velocity, like that it's moving like this. So after a certain time, it will hit another electron. So after hitting, will collision increases or decreases? Yes or no? Somewhat decreases. Then it will go and hit another electron. Then after collision, that electron velocity also decreases. Then what happens? The overall constant velocity. Okay. So the average of constant velocity is called. Average constant velocity is called drift velocity. Okay. Simply we can say, so orally, okay, so after keep on bombardment, keep on collision takes place. Okay, so one electron loses another velocity. So one electron is coming with some velocity and hits another electron. So here first electron will loses the velocity. After that again it will go and hit another electron. There also, electron loses velocity like that. The average constant velocity is called drift velocity. Right? Yes. Now, here when electrons are moving in a conductor, when electrons moving in a conductor, it experience the magnitude of force. Yes or no? It experience the magnitude of force. That is F equal to EER. Oh, we can also write like this. That is, either you can write like this or you can write like this. Okay. So when it experiences the magnitude of force, then it produces acceleration. Yes or no? It produces acceleration because so electron is moving forward. So initial velocity and final velocity difference is there, right? So then it produces acceleration. So acceleration, yes or no? F equal to ma. So then ma equal to E into U or Q into E or A equal to E by M, and we can also write Q by M, right? Yes or no? Yes. So here you can observe this, the current is moving like this, electron is moving opposite to the current direction. So drift velocity will be like this. Okay, opposite of current direction. Okay. Sir, you said relaxation time. What is that? So I already mentioned, one point. So this electron is going to hit another electron. That electron is going to hit another electron. Here collision takes place. After, so first collision takes place. Again this electron will go and hit another electron, right? Yes or no? So immediately we'll go to the next collision. So there is a time gap between one collision to another collision. Yes or no? So the average time gap between two successive collisions is known as relaxation time. The average time gap between between two successive collisions. So two successive collisions is called relaxation time. So one collision will take place. One electron will hit this electron. So here and again it goes to the and hit another electron. So the gap is, okay, this time is there, right? It will take certain time to go to occur. So it goes to the next collision. So between one collision to another collision, there is a time. Yes or no? Yes or no? Some time gap is there here to here. So overally, the average time between two successive collisions is called relaxation time. Is called relaxation time. So that is denoted with tau. I hope it is very clear. Understood or not? So this is about drift velocity and relaxation time. So coming to the next one, current and drift velocity. Current and drift velocity. Current and drift velocity. Current and drift velocity. What is that? Current and drift velocity. Current and drift velocity. Between electrons, my electrons. So collision will takes place between electrons only. So current and drift velocity. 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 So here this is the conductor. So this is the area of the cross section. This is also area of the cross section A. Area of the cross section A. Understood or not? So now this is the electron. This is the electron. Electron is moving. Okay. So current is moving in this direction. Current is moving opposite to the electrons flow. So now, so this is the length. So I'm taking, suppose, no, V equal to L by T. Okay, L equal to V into T. That is nothing but Vd into delta T. That is the length. So what about volume? Volume equal to length into area of the cross section, Vd into delta T into A. That is the volume. Okay. So number of electrons present in the particular volume. Number of electrons present in the particular volume. That is nothing but electron density into Vd into delta T into A. Now, so charge can be obtained by multiplying N Vd delta T into A into E. So current I equal to delta Q by delta T. Then we can take NEA Vd into delta T by delta T. So here delta T delta get cancelled. I equal to NEA Vd. Okay, so this is the relation between current and drift velocity. Okay. Understood? Understood? Electrons and ions. Ions are present in the material. Okay. So point masses only. Point masses only. Okay, I hope it is very clear. So this is about current and drift velocity relation. So now we will discuss about resistance and resistivity. Oh my God. Resistance resistance, 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 resistance. Resistance, 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 resistance. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. No, 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 no. And here you can observe, I'm talking about resistance and resistivity. Resistance is nothing but the phenomena of opposing the electric current in the circuit. The phenomena of opposing the electric current, okay, is called resistance. The phenomena of opposition, okay, so it opposes the electric current. That is called resistance. So resistance depends on resistance. Resistance depends on length of the conductor. Resistance depends on area of so cross section. Here you can observe R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R equal to L by A. R equal to rho into L by A. Rho is the resistivity. Rho is the resistivity. Yes or no? So resistance depends on temperature. Resistance depends on nature of the material. Nature of the material. So coming to here, so resistivity equal to RA by L. SI unit of resistance is ohms. SI unit of area is meter square, and SI unit of resistivity is ohm meter. Okay. So here you can observe resistivity depends on temperature. Resistivity depends on nature of the material. Nature of the material. Understood or not? Nature of the material. Okay. So resistance depends on resistance depends on resistance depends on length and area of the cross section. Resistivity depends on temperature and nature of the material. Even resistance also depends on temperature, nature of the material, and resistance depends on length and area of the cross section. So this is about differences of resistance and resistivity. Okay, so now we will discuss about temperature dependence of resistance. 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 Dependence of resistance. So those who are there in the class, do like, share, So if you like the content, just click on like button. Just click on like button. If you like the content, if you like my explanation, just click on like button. So if you like the content, you can subscribe the channel. Okay. So once you go and check the channel content, then if you like it, you can do like, share and subscribe to Student Brand. Okay. Temperature dependence. So here, so 2 points will take place when temperature, resistance and resistivity. And coming to the temperature, resistance and resistivity. Okay, so 2 points. Point number 1. When temperature increases, the free electrons in the conductor increases. Yes. So movement, amplitude, so velocity of the free electrons increases. So because of that reason, the electrons start moving. So by that, when temperature increases, so these two situations will happen at a time. That's why individually I am discussing. Point number 1. When temperature increases, as soon as you increase the temperature, the free electrons movement increases. So electron will start moving. By that, conductivity increases, resistance and resistivity decreases. When electron is start moving, keep on moving with the greater amplitude. Okay, the greater amplitude, what happens? Then that electron will hit another electron. Collision will take place. When keep on electrons are bombarding, collisions between electrons takes place. Then what happens? Resistance and resistivity increases. Resistance and resistivity increases, conductivity decreases. Yes or no? Resistance and resistivity increases, conductivity decreases. I hope it is very clear. Understood or not? So these are the points. So alpha is the temperature coefficient of resistance. Alpha is the temperature coefficient of resistance. So here you can observe RT equal to R naught 1 plus alpha into T minus T naught. Then we can take RT equal to R naught plus R naught into alpha T minus T naught. Then RT, resistance at temperature, so alpha T minus T naught. Then alpha equal to RT, then R naught into T minus T naught. Okay. So here you can observe, we know R is directly proportional to L, R is inversely proportional to area of the cross section, R is directly proportional to L by A, R equal to rho into L by A. So here is one point. When temperature increases, length and area of the cross section also increases. Okay, actually these two are very quite small. So those are very small in expansion. So that's why R is directly proportional to resistivity. So R is directly proportional to rho. Then we can write finally alpha equal to rho T minus rho naught by rho naught into T minus T naught. Okay. So in that case, alpha is the temperature coefficient of resistivity. Is it clear? Is it clear? Is it clear? right? Yes. So I hope it is very clear. Understood or not? So next one we will discuss about resistance and resistivity completed. Next one we will discuss about Ohm's law. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Na, na, na. So next one, so we'll discuss about Ohm's law. Okay, we'll discuss about Ohm's law. Understood or not? Ohm's law. So if you like the content, if you like the channel, do like, share and subscribe. So if you like the content, if you like the channel, if you like my explanation, do like, share and subscribe to Student Brand and share to your friends, ask your friends to join to the class. Once check the channel. If you are liking, if you are observing this class, if you're watching this class, just check the channel, then you'll get to know. Okay, so now Ohm's law. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature and physical conditions also same. V is directly proportional to I, V equal to IR. So the graph of Vi gives, so the slope of Vi graph gives the resistance. So V on y-axis, I on x-axis. The graph is here. So it is angle theta. That is the tan theta equal to R. Slope. Okay. Understood? I hope it is very clear. V is directly proportional. So this is for ohmic conductors, sir. What do you mean by ohmic conductors and non-ohmic conductors? Ohmic conductors. And the second one is non-ohmic conductors. Ohmic conductors and non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Okay, Vi graph is straight line starting from origin. Right? Yes or no? So it is a linear. Now, so we can take the graph for non-ohmic conductors. This is for non-ohmic conductor, this is for ohmic conductors. Okay, the graph is like this. V on y-axis, I on x-axis. So here you can observe V1. Here this is the V1, V1, I1, V2, I2. Okay. So now you can observe here in this case. So R1 equal to, normally R equal to V by I, right? R equal to V by I. V1 by I1, R2 equal to V2 by I2. But R1 is not equal to R2. So for ohmic conductor, the graph is curved. So non-ohmic conductor, the graph is curved. For ohmic conductor, the graph is straight line. starting from origin. Okay. So I hope it is very clear. Understood or not? Is it clear? Is it clear? So this is about Ohm's law. Next one. So I'll discuss about one more. That is about electromotive force. Electromotive force. EMF. EMF. If you like the content, if you like the channel, do like, share and subscribe to Student the Brand. Check the channel. So once again, electromotive force, EMF. So what is it? So now you can see here. Electromotive force. Electromotive force. EMF. EMF. So here you can observe, normally when you connect cell to the resistor like this, current is start flowing. Okay, so positive charge will move from positive terminal to negative terminal. Understood, na? So positive charge will move from positive terminal to negative terminal. Right? So what about when positive charge is reached to the from negative terminal to positive terminal also, the positive charge should move, right? Low potential to high potential. So we know when you connect cell to the circuit, automatically positive charge will move. Okay, positive charge will go from positive terminal to negative terminal. So how the positive charge will move from low potential to high potential in the cell or battery? So there is an influence. The influence making the positive charge to move from negative terminal to positive terminal, low potential to high potential. The force which is responsible for the movement of positive charge from negative terminal to positive terminal, that is called electromotive force, EMF. So E equal to W by Q, work done by the battery on the charge to move from positive terminal to negative terminal, that is called EMF, electromotive force. Okay, so next one we will discuss about, okay, what is that? Next one we will discuss about resistors are connected in series combination, resistors are connected in parallel combination. Resistors are connected in series combination, resistors are connected in parallel combination. So what is that? Resistors are connected in series combination. Resistors are connected in series combination. Series combination. So here you can observe resistors. So resistance is a phenomena. Okay, ma. So I'll explain thermodynamics. So I'll do that. Yeah, that also. So in coming class I will be explaining internal resistance and everything. Okay, internal resistance, external resistance, everything I'll explain. In the cell it will be there, internal resistance. When electron is moving through electrolyte, it experiences resistance, that is the internal resistance. So when electron is moving, current is there. So there is a potential drop. So EMF of the cell is not actually overall EMF. So there is an internal resistance in the cell, that is the overall potential is V equal to E minus IR. That I will discuss. Okay, fine. Same thing I will explain. So now we are discussing about resistors are connected in series combination. What is that? Resistors are connected in series combination. So I am taking here, this is 1, 2, 3. So this is R1, R2 and R3. Then that I am connecting to the circuit. V1, next V2, next V3. So positive, negative, positive, negative, positive, negative. So current is flowing. Now you can see here, throughout the circuit current is same. Yes or no? Throughout the circuit current is same. Then IS equal to I1 equal to I2 equal to I3 equal to I. From Ohm's law, V equal to IR. V equal to IR. So then Vp equal to V1 plus V2 plus V3. That is nothing but IRP equal to IR1 plus IR2 plus IR3. Then I am taking I common. So I am taking common R1 plus R2 plus R3. So I get cancelled. Rp equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, if n number of resistors are connected, if n number of resistors are connected in series combination, okay, so what is that? This is RS, right? RS. So resistors are connected in series. These are series. These are series. These are series, right? RS, R equivalent. So RS or R equivalent, we can write RS equal to NR. RS equal to NR. So potential difference in series combination. VS, IRS, IRS. So I anyway same. So we are taking out. So now the final answer is this one. Okay. So that's enough. RS equal to NR. Understood or not? So now we will discuss about one more. We will discuss about one more. Resistors are connected in parallel combination. 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 Combinations. Resistors are connected in parallel combination. Resistors. So not only this class, you have to do extra hard work also. Then it will be so full complete work. By listening only classes, you may not get 100%. Okay, for any class. So for any class, so I am telling only listening the class, you will not fulfill your complete preparation. So you have to listen the class, you have to read the books. Okay, so you have to compare and concepts. So you have to work out. So and where we need to concentrate, where we need to focus, everything you should know. Your strength and your weakness, where you are lagging, where you are strong, you should only know. Okay. So if I say only these concepts enough, but what about your preparation? Whether you prepared or not, it depends. So where you focus, where you are, somewhere you will may miss the concept, somewhere you may prepare. So there are so many factors. So you have to listen the class, understand the concepts, and take the books. So whatever you are following, take the help of books. Okay, so along with the classes, okay, along with the guidance. So you have to do your own work. Okay, so with the reference books, your own notes, everything, and a number of okay PYQs practice. Then you have to write so many papers. After that, so by getting your scores based on that one, how much confidence you are, so how better you are doing in the exams, then you have to improve slow by one. So like that, so many factors are there. There are so many factors. There are so many factors. Yeah, problems we are doing. So problems also I'll discuss. That all I am saying that, and right now, so according to the situation, I am going with the concepts. So problems also will do practice, definitely, one by one. Okay, so we can't do all the things at a time. So slowly, one by one, definitely I will include the problems. So see, one problem it will take full board. So if by writing one problem only, it will take full board. That type of questions will be there, right? So slowly, one by one, definitely I will include, right? So now we are concentrating on the concept, so focus on it. Then we'll be flowing one by one. Now, so parallel combination. So resistors are connected in parallel combination. Now you can see here, right? So R1, R2 and R3. So here I1, I2, I3, then so here V is there, V. So now resistors are connected in parallel combination. Resistors are connected in parallel combination. Now you can see. So Vp equal to V1 equal to V2 equal to V3 equal to V. Then we know V equal to IR. I equal to V by R. Then IP equal to I1 plus I2 plus I3. Okay, then V by Rp equal to V by R1 plus V by R2 plus V by R3. Then V I am taking common. 1 by Rp equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So V get cancelled. So 1 by Rp equal to, what is the formula? 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So then, if number of resistors are connected in parallel combination, N by R, so Rp equal to R by N. Rp equal to R by N. Understood or not? So this is very, very important. So if you like the content, if you like the explanation, if you like the channel, do like, share and subscribe to Student the Brand. So share to everyone, inform to everyone, ask your friends to join to the class. So just check the concepts. Okay. Yeah, that is true. Himanshu. So H.C. Verma, Singh, D.C. Pandey. Okay, done. I hope it is very clear. Resistors are connected in series and parallel combination. Next, Kirchhoff laws. So, all circuit we cannot reduce into simple series and parallel. Okay. So, we cannot. Okay. Now we'll discuss about Kirchhoff laws. Kirchhoff laws. Kirchhoff laws. Okay. So as I said, so many circuit cannot simply so let me complete. So few topics are there. So after completion of these topics, then we will discuss. Okay, done. Let's start. Kirchhoff laws. One is junction law. So and second one is loop law. Loop law. So coming to the junction law, sum of the algebraic sum of all the currents meeting at a junction is 0. The algebraic sum of all the currents meeting at a junction is 0. Algebraic sum of all the currents. So nearly it will take half an hour more. So maybe 20 to 30 minutes. 100 to. So here you can observe junction law. Junction law you can observe here. I1, I2, I3, I4. So here you can see I1 plus I2 equal to I3 plus I4. Sum of the currents reaching to the junction or sum of the currents entering into the junction is equal to sum of the currents reaching to the junction. Okay, so coming to loop law. So here are 4 points. Point number 1. So this is cell. So point A and this is the point B. So negative terminal, positive terminal, this is the path. Okay, so the EMF is positive because we are moving from negative to positive terminal. Negative to positive. That's why EMF is positive. And coming to the second one. So A, B, positive terminal, negative terminal. So this is the path. So now EMF is negative. What is that? Because we are moving from positive terminal to negative terminal. Coming to third one. Resistor, A, B. Resistor, current is moving like this. So if the path is along the current direction, then it is going to decrease in potential. The IR term is negative. Coming to the fourth one, if it is going, so A, B, R, and current is moving here, the path is like this. You are moving opposite to the current direction. Okay. Now the IR term is positive. Okay, IR term is positive. So these 4 points, if you know that, then you can solve any circuit. You can write a equation. Okay. Write a equation. So I hope it is very clear. Just check once. Kirchhoff laws. Next, so we'll discuss about internal resistance and potential difference. Internal resistance and potential difference. So these points are very, very important. Internal resistance and potential difference. So when an electron is moving in a cell, it experiences, actually it is moving in electrolyte. When electron is moving in an electrolyte, it experiences some resistance. So when it is moving in a cell, okay, so negative terminal to positive terminal to negative terminal, so positive terminal to negative terminal, then negative terminal to positive terminal, it's moving, right? So when it is moving through electrolyte, it experiences some resistance, internal resistance, that is smaller. Okay, and capital R, anyway, we are outer side, we are bulb, so all the devices we are connecting, so there is external resistance. Internal resistance means within the cell, when electrons is moving, it encounters a resistance, that is internal resistance. So potential equal to EMF minus IR. Because resistance is there, automatically there is a potential drop, means reducing current. Okay, somewhat. Right. So that's enough. Next one, heating effects of electric current. The algebraic sum of all the potential difference in a closed loop in a circuit is 0. So that we can say, right? Yes. So now, so where we are? Heating effects of electric current. Heating effects of electric current. So here you can observe V equal to W by Q. So from this W equal to V into Q. We know Q by T is current. The rate of flow of charge is called current. Yes or no? Yeah, I already said no, so few problems I'll take and do it. Okay. So meanwhile, so you can try to solve it. Like this, positive, negative. So current are here, positive, negative, positive. So here, this is R. So current is passing like this, like this, like this. So I'm taking the direction like this only. Then you can take, this is IR term. Along the current direction we are moving. So this is R1, R2. I am taking this E1 and E2. So R1, E1, R2, E2. Like that you can apply. Now you can apply the rule, loop law, then you will get it. Yeah, you can take. So I'm taking this the path, right? Minus I R1. Here you can take positive or negative? Positive. Yes or no? Plus here in the same direction. Same current I R2. Then again positive equal to 0. Like this. This is the equation. Check once. I R1 because same direction. And here also, so it's going negative to positive E1. So potential is positive. So here EMF is positive. Again it is moving the same direction. Current direction only we are taking the path. So IR term is negative. So if it is opposite, if the current is moving like this, if you are taking the path opposite, then it is positive. Okay. Then like that. Yeah, positive only I took right here. So like that E equal to 0 we can take. So this is one example. Like that we can take it any circuit or any loop we can solve, no problem. It's very simple, but the path which direction you are taking, that is very important. So be careful where you are taking the path. So according to the path, anyway current direction we will get to know. So positive terminal to negative terminal. Current direction positive terminal to negative terminal. So over across the cell when you are going, when you are passing through the cell, positive to negative or negative to positive, check once and take. And across the resistor, when the according along the current direction negative, opposite to current direction positive. Okay. So now you can see here. Now you can see here. So V equal to W by Q. So P equal to W by T. So you can see P equal to W by T. VQ by T. Then P equal to Q by T is I. Then E equal to P into T. Then VI into T, that is nothing but H. The source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. It is also known as Joule's law of heating. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Okay. So I hope it is very clear. That is about heating effect of electric current. So next one, grouping of cells. Grouping of cells. Dun, 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 dun. Grouping of cells. Grouping of cells. Grouping of cells. Grouping of cells. So grouping of cells you can take. Here cells are connected in series combination. 1 resistance, 2 resistance, 3 resistance. Then I'm connecting to the external resistance R. So E, R, E, R, E and R. External resistance, current is flowing. Now resistor cells are connected in series combination. Series combination. Okay. Series combination. Coming to series combination. Now you can observe. So E and R of each cell is common. E and R of each cell is common, right? Now you can take here net EMF. Net EMF is NE and net resistance, net internal resistance. Net internal resistance. Okay, net internal resistance is NR. Total resistance. Total resistance equal to NR plus R. Now, current I equal to net EMF by total resistance. Total resistance. Okay, that is nothing but NE by NR plus R. That is current. Okay. So this is about cells are connected. Cells are connected in series combination. Next, cells are connected in parallel combination. Okay, let's start. Cells are connected in parallel combination. Cells are connected in parallel combination. Okay, so here you can take okay. So E and R, E and R, E and R and R. Now, so here you can observe. Now we can observe here. So E and R of each cell is common because all are connected same only. All positive points are connected to one junction. All negative terminals are connected to another junction. So now net EMF equal to E because EMF is same in parallel combination. Net internal resistance. Net internal resistance. net internal resistance R by N. Okay, actually 1 by Rp equal to N by R, Rp equal to R by N in parallel combination. So before we discussed in resistors are connected in series. So now you can see total resistance. Total. So total resistance, if you are taking total resistance R plus R by N. Okay, R plus R by N. Now I equal to net EMF by total resistance. Total resistance. Okay, so net EMF is nothing but E, but total resistance is R plus R by N. That is I. Okay, so I hope it is very clear. So if you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Study in the Brand. This is our Sir from Study in the Brand. If you like the content, if you like the channel, if you like my explanation, so inform your friends, ask your friends to join to the class, share to everyone. Okay, so share as many as possible, as much as possible. Thank you so much. Signing off. Thank you all.